Hello students, welcome to TX Quick Learn. This is 10th class, chapter 3, exercise 3 and exercise 3.3. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficient. For the quadratic polynomials, if we want to find the zeros, then we have to follow this method. So this is called factorization method. So x square minus 2x minus 8. This can be written as, so x square minus 2x can be written as minus 4x plus 2x. If we do minus 4x plus 2x, we'll get minus 2x. And minus, if we check 8, we can write 8 minus 8 as minus 4 into 2. So if we see here, we can see the common factors. So in the first two terms, x square minus 4x, x is common here. So if we take x common, and we will be having 1x and minus 4, plus if we see the last two in the sum, so 2 is common. If we take 2 common, then x minus 4. So if we see in these two terms, x minus 4 is common. So if we take x minus 4, and then x plus 2 will be left out. So if we want to find the zeros, x minus 4 is equals to 0 and x plus 2 is equals to 0. If we send the integers after equals to 4 and x is equals to minus 2. So if we see the quadratic polynomial x square minus 2x minus 8 have the zeros 4 comma minus 2. Then in the question they have asked about the relationship, to verify the relationship between the zeros and the coefficients. As we know, if we check here, minus of coefficient of x. What is the minus of coefficient of x? This is the sum of the zeros. Sum of the zeros is equals to minus of coefficient of x by coefficient of x square. That is the formula. And if we verify this sum of the zeros with the minus of coefficient of x by coefficient of x square, we will get the same thing. That is minus of coefficient of x will be minus 2 by coefficient of x square. What is the coefficient of x square? It is 1. So if we check, the answer will be minus of coefficient of x. What is the coefficient of x? 2. 4 minus 2 by 1 is, it is 2. The answer is 2. Product of the zeros, if we check, 4 into minus 2, that is minus 8. If we check the constant term, what is the constant term here? Minus 8 by 1. Coefficient of x square, if we check, it is 1. So it is, if we verify the relationship between the zeros and the coefficient, it is satisfying. And the next, 4s square minus 4s plus 1. This can be written as, so 4s square, how can we write it as? 2s into 2s, which gives 4s square, minus 4s can be written as minus 2s. So plus 1 is as it is. If we check the first two terms, 2s is common. If we take 2s common, 1 2s is left out, minus 1. If we take the 2s completely common, then only 1 is left out, minus 1. And like in the last two terms, we are taking minus 1 as common because we want 2s minus 1. So in these two terms, in the third step, if we check, 2s minus 1 is common. And here also 2s minus 1 is common. To find the zeros, if we want to find the zeros, s is equals to 1 by 2. S is equals to 1 by 2. So the zeros of the polynomial 4s square minus 4s plus 1 are 1 by 2 comma 1 by 2. So if we check the coefficient of s square, it is 4. Coefficient of s is minus 4 and constant term is 1. If we check the sum of the zeros, if we add those things, we'll get 1. That is minus of, if we want to verify the relationship between the sum of the zeros and product of the zeros, the formula is minus of coefficient of s by coefficient of s square. If we check coefficient of s, what is the minus of coefficient of s? Is minus of minus 4. The middle term, if we check, it is minus 4 by coefficient of s square is 4. 4 ones are 4. So minus of minus is plus. If we check, we get the answer 1 by 1. If we check the sum of the zeros, that is also 1 by 1. Here if we check the relationship here, that is also 1 by 1. That is sum of the zeros is equals to this formula. So we can verify that sum of the zeros is equals to minus of coefficient of s by coefficient of s square. If they check the product of the zeros, 1 by 2 into 1 by 2, that is 1 by 4. If we check what is the constant term is 1 and coefficient of s square is 4. If we check 1 by 4, so here also this is it is satisfying the condition. So we have verified that it is a constant term by coefficient of s square is the product of zeros is equals to constant term by coefficient of x square. We are just verifying it. Coming to the third bit, 6x square minus 3 minus 7x. So here the order is not proper. That means x square is there, but x power 1 should be the next term, but here it is minus 3. So like we have to write it in an order so that we can do the sum easily. So 6x square minus 7x minus 3. 6x square minus, how can we write 7x, like how can we divide? So minus 9x plus 2x minus 3. So in these terms, 3x we can take common. If we take 3 common, 3 2s are 6 and 1x is left out. Minus 3 3s are 9. So x is already taken common. 2x minus 3 is the term left out. So here in the last two terms we can take one common. I missed to write that, sorry for that. 2x minus 3. So if we check these two terms, 2x minus 3 is common, 3x plus 1. To find zeros, 2x minus 3 is equals to 0, x is equals to 3 by 2, 3x plus 1 is equals to 0, x is equals to minus 1 by 3. So now we have found 3 by 2 and x is equals to minus 1 by 3. These are the zeros. Now we have to verify the sum of the terms and the product of the terms is this formula. How to verify that? First we need to find the sum of the terms. If we do sum of the terms, we'll get minus of 7 by x. So if we check minus of, what is the coefficient of x? Coefficient of x is minus 7 by 6. 9 minus 2 by 6 means 7. There is a minus here, please ignore that one. It is not minus, it is 7 by 6. If we check minus of minus 7 by 6, that means the 7 by 6 is matching with this 7 by 6. Minus of minus will be plus. So 7 by 6 minus of coefficient of x by coefficient of x square gives you the sum of the terms. It is both are same. That means we have verified it. Product of the terms, 3 by 2 minus 1 by 3. That is minus 3 by 6. Constant term is 6 here. Sorry, the constant term is 3 here. If we check the constant term, it is minus 3. Minus 3 by coefficient of x square is 6. And if we check in the above equation, it is matching. So we have verified that sum of the terms is equals to minus of coefficient of x by x by coefficient of x square. In the product of the terms is equals to constant term by coefficient of x square. Next bit is 4u square plus 8u. This can be written as 4u square plus 8u plus 0. Since the constant term is not given, we can write it as 0. So if we check these two terms, we can take 4u common here. If we take 4u common, we are left out with 1u plus 4 2s are 8. 4u u plus 2. So 4u is equals to 0, u plus 2 is equals to 0. U is equals to 0 and u is equals to minus 2. So the zeros of the polynomial are 0 comma minus 2. If we check the coefficient of u square, it is 4, coefficient of u it is 8 and constant term is 0. If we check the sum of the zeros, 0 minus 2 is minus 2. What is the formula? That is minus of coefficient of u by coefficient of u square. Minus of coefficient of u. What is the coefficient of u? It is written as 8 by coefficient of u square is 4. If we cancel that one, 4 of minus 2. So this minus 2 is matching with the sum of the zeros, minus 2. That means we have verified that this formula is satisfying this condition. Product of zeros. Next, product of zeros is 0 into minus 2, that is 0. Constant term. What is the constant term? It is 0. By coefficient of x square is 4. The answer is 0. That means here also we have verified that coefficient of sum of the zeros is equals to minus of coefficient of u by coefficient of u square. Here also product of zeros is equals to constant term by coefficient of u square. T square minus 15. This can be written as t square plus 0 into t minus 15. So here we can write as t square is equals to plus or minus root 15. So t is equals to plus root 15 or t is equals to minus root 15. Zeros is equals to 15 minus root 15 with that, which is 0. If we check the coefficient of t, we don't have any term for coefficient of t, that is 0. By coefficient of t square is 1. If we check, the relationship is matching. Sum of the zeros is equals to 0. So minus of 0 by 1, that is 0. Sum of the zeros is equals to 0, and if we calculate this is also 0. Product of zeros, if we check, root 15 into root 15 is 15, and minus it is plus root 15 and minus root 15. Plus into minus is minus. Root 15 into root 15 is 15. Minus of constant term by coefficient of t square. What is the constant term? It is minus 15 by coefficient of t square is 1, which is satisfying the condition. Next bit is 3x square minus x minus 4. This can be written as 3x square minus x minus 4. So 3x square plus 3x minus 4x minus 4. 3x if we take common, x plus 1 minus 4 of x plus 1. X plus 1 common in these two things, 3x minus 4. X plus 1 is equals to 0, 3x minus 4 is equals to 0. X is equals to minus 1, x is equals to 4 by 3 are the zeros of the polynomial. Some of the zeros will be, if we calculate this, we get 1 by 3. If we check the coefficient of x, it is minus 1. Minus of minus 1 by 3, which is equal to sum of zeros. Product of zeros, if we check also, minus 4 by 3, which is constant term by coefficient of x square. Coming to the next bit, that is find the quadratic polynomial in each case with the given numbers as the sum and product of its zeros respectively. So 1 by 4 comma minus 1. Let the quadratic polynomial be ax square plus bx plus c, where a not equal to 0. If a is equals to 0, then it becomes a linear polynomial but not the quadratic polynomial. So a not equals to 0 and its zeros be alpha and beta. Here alpha is equals to 1 by 4. Here in the question they mentioned that sum and product of its zeros respectively. That means alpha plus beta is equals to 1 by 4 and alpha beta is equals to minus 1, because they mentioned sum and product of its zeros. So sum of the zeros is 1 by 4, product of the zeros is minus 1. So the quadratic polynomial for ax square plus bx plus c is equals to 0 is k of x square minus alpha plus beta into x plus alpha beta. This is the formula. So if we check, x square minus 1 by 4x into alpha beta is minus 1. If we assume k as 4, 4x square minus x minus 4 will be the answer. So the quadratic polynomial will be 4x square minus x minus 4, where k not equals to 0. K not equal to 0. If k is equals to 0, then the whole quadratic polynomial itself will become a 0. So we don't take k as 0. So the second bit is root 2 1 by 3. So alpha plus beta is equals to root 2, alpha beta is equals to 1 by 3. The quadratic polynomial will be k of x square minus alpha plus beta into x plus alpha beta. K of x square minus alpha plus beta, what they have given is root 2. If we substitute root 2, then it will be root 2 into x plus 1 by 3. If we check, if we multiply 3 of in place of k, we get 3x square minus root 2 x plus 1. 0 comma root 5. Let the quadratic polynomial be x square plus bx plus c, comma a not equals to 0 and its 0 be alpha and beta. So alpha plus beta is equals to 0, alpha beta is equals to root 5. The quadratic polynomial b x square plus bx plus c is equals to 0 is k of x square minus of alpha plus beta into x plus alpha beta. In place of alpha plus beta, what they have given is 0. In place of alpha beta, what they have given is root 5. If we substitute these things, we'll get x square plus root 5. If we take k as 1, then the polynomial will become x square plus root 5. Fourth one is 1 comma 1. Let the quadratic polynomial be x square plus bx plus c, a not equals to 0, and alpha comma beta are the zeros. But in the question they have given alpha plus beta is equals to 1 and product of zeros alpha beta is equals to 1. The quadratic polynomial be k of x square minus of alpha plus beta into x plus alpha beta. And alpha plus beta, what they have given is alpha plus beta into x plus alpha beta, x square minus x plus 1, k of x square minus x plus 1. If it assume k as 1, the quadratic polynomial will become x square minus x plus 1. Next bit is minus 1 by 4 comma 1 by 4. Let the quadratic polynomial be x square plus bx plus c is equals to 0 and a not equals to 0. Sum of the zeros will be alpha plus beta is equals to minus 1 by 4, which is given in the question. Product of zeros will be alpha beta, that is 1 by 4. Quadratic polynomial for ax square plus bx plus c is equals to ce is k of x square minus of alpha plus beta into x plus alpha beta, where k not equals to 0. X square minus of, what is the alpha plus beta they have given is minus 1 by 4, x plus 1 by 4. So if we multiply k with 4, then 4x square plus x it becomes, because minus of minus will be plus x plus 1, because the 4 will be multiplied, which will be cancelled. So the quadratic polynomial for the sum and the product of zeros minus 1 by 4 comma 1 by 4 is 4x square plus x plus 1. And sixth bit is 4 comma 1. Let the quadratic polynomial be ax square plus bx plus c, comma a not equal to 0, and its zeros be alpha and beta. Sum of the zeros given in the question is alpha plus beta is equals to 4 and product of zeros is equals to alpha beta is equals to 1. So we know the formula, that is the quadratic polynomial of ax square plus bx plus c is k of x square minus of alpha plus beta. What is the alpha plus beta? It is 4x plus alpha beta is 1, where k not equals to 0. If k is not equals to 0, the k will start from 1 to quadratic polynomial for the sum and the product of zeros. 4 comma 1 is x square minus 4x plus 1. Coming to the next bit, that is find the quadratic polynomial for the zeros alpha beta given in each case. In the previous problem, it is sum of the zeros and the product of the zeros. Here they have mentioned zeros, that means alpha and beta they have given. We need to find the alpha plus beta and alpha into beta in this question. So 2 comma minus 1. Let the quadratic polynomial be ax square plus bx plus c, comma a not equals to 0 and its alpha and its zeros be alpha and beta. So alpha is equals to 2, beta is equals to minus 1. If we do sum of the zeros, alpha plus beta is equals to 2 minus 1, which is 1. Product of zeros will be alpha into beta, that is 2 into minus 1, that is minus 2. So if we check the quadratic polynomial ax square plus bx plus c is k of x square minus of alpha plus beta into x plus alpha beta. If we substitute the zeros that we found, k of x square minus of, what is that sum of the zeros? 1. X plus of minus 2. That is, if we assume k is equals to 1, then x square minus x minus 2 will be the quadratic polynomial for the zeros 2 comma minus 1. Sum of the product for the zeros 2 comma minus 1. So the next bit is root 3 minus root 3 are the zeros. So if we find the sum of the zeros, then it will become 0. Product of the zeros, it will become minus into minus root 3 plus into minus is minus, root 3 into root 3 is 3. The quadratic polynomial for x square plus bx plus c is k of x square minus alpha plus beta into x plus alpha beta, where k is a constant and k not equals to 0. If we assume k is equals to 1, x square minus 0x minus 3, that is x square minus 1 by 4 comma minus 1. Let the quadratic polynomial be ax square plus bx plus c, comma a not equals to 0 and its zeros be alpha and beta. So here alpha is equals to 1 by 4, beta is equals to minus 1. Sum of zeros will be alpha plus beta is equals to minus 3 by 4. Product of zeros will be minus 1 by 4. So the quadratic polynomial ax square plus bx plus c is k of x square minus of alpha plus beta into x plus alpha beta. Next bit is 1 by 2 comma 3 by 2. Alpha, let the quadratic polynomial be ax square plus bx plus c is equals to 0, a not equals to 0, and alpha and beta are the zeros. Alpha is equals to 1 by 2, 4x square minus x plus 3. And the final bit is verify that 1 minus 1 plus 3 are the zeros of the cubic polynomial x cube, that this is not x square, it is x cube minus 3x square minus x plus 3, and check the relationship between the zeros and the coefficients. So this is x cube, sorry for the mistake. Here let the cubic polynomial be ax cube plus bx square plus cx plus t, and a not equals to 0, and the zeros will be alpha, beta and gamma. Alpha is equals to 1, beta is equals to minus 1, gamma is equals to 3, and some of the zeros will be this one, and you will get answer as 0. Like here it is not like they are asking us to verify that these are the zeros. How can we verify that? If we substitute in place of x all these values, then we'll get 0. So if we substitute, we got the answer 0. If we substitute minus 1 also, we'll get the answer 0. If we substitute gamma also, we'll get the answer 0. And relationship, if we want to find, some of the zeros will be 3 by 1. If we for this the relationship will be minus of coefficient of x by coefficient of x cube. This is the coefficient of x square, minus of coefficient of x square by coefficient of x cube. If we check, minus of coefficient of x square is 3 minus 3. If we check, we will get answer 3. That means it's satisfied. If we check the product of this sum of the product of zeros, if we substitute, we'll get minus 1 by 1, that is the coefficient of coefficient of x is minus 1 by coefficient of x square is minus by product of zeros will be alpha, beta, gamma, that is constant minus of constant term by coefficient of x cube, which gives the answer. That means it is verified. Thank you.